All right. So let's start. I'm gonna. Every table, you and your partner, I want you to get one of these whiteboards and turn it to the graph side. Okay. Turn it to the graph side. Have your expo markers right here. Grab an expo marker. Okay. Just one per table. You guys can share them. Okay, you can use this along with your notes, okay, as we go through this stuff. Okay, every table has a whiteboard? Everybody has one? Okay, so let's start with talking about, let's start with something simple, okay? Don't put this on your notes. This is not an example. I'm just going to kind of show you what I'm thinking here. Okay? All right, let's. Okay, Michael, will you roll those so that those shades are open? Same thing, Lacey, so we have a little light. Okay, so somebody give me a point on the graph. Samir, give me a point on the graph. 3-1. Okay, everybody graph 3-1. First of all, if I'm going to graph the point 3-1, okay? What does that mean? Which one? What is the first value in my order pair? Does that mean he's like X or Y? X. So I'm going to go over 3 and up how many? Okay. Let's say I have another point. Let's just say right here. Okay. All right. Graph those on your whiteboards. Okay. If I asked you to find the distance between those 2 points, could you do it? Okay, what's the distance between those 2 points? Now, we don't have a specific unit here. We'll just say units. What is it?
6.
6, right? You were able to find that. Why? Because they're what? Because they are on the same line, right? So let's take another 2. Okay, let's graph, let's say -4, 3. And let's say, we'll say -4, 7. Okay. If I asked you to find the distance of those, could you do it? Okay, what is that distance? It's easy when what? They're on the same line, right?
I think it's 4.
Okay, it's easy when they're on the same line. I may have graphed that. That 7 might be one up. Okay, but the point is, when they're on the same line, it's easy to find the distance, right? Okay, so what if I said I wanted you to find the distance between, let's say, these 2? Okay, and I wanted you to give me an exact distance, close to an exact distance. Okay, why might that be a little more difficult? Okay, if I look at this, if I'm going from here to here, is it going straight through some of these points? How it goes pretty much a little more than, it cuts off a little more than half on this one. This one it's only a quarter. This one, it does, in other words, it doesn't go straight through points like that one would, does it? Right? Okay, so what we're going to do, this is your objective. You're going to write this in your notes, okay? Your objective is today, determine distance on the coordinate plane. Determine distance on the coordinate plane using the Pythagorean theorem. Using the Pythagorean theorem. Okay, do I need to repeat that, or are we okay? Determine distance on the coordinate plane using the Pythagorean theorem. Okay, are we good? Okay, right below where it says objective. Okay, let's just do a quick refresher of what the Pythagorean theorem is, okay? Okay, this is distance on the coordinate plane. Oops.
Why did you put
I don't know. Okay, distance on the coordinate plane, okay? So somebody tell me, what is the Pythagorean theorem? Quick review. What is the Pythagorean theorem? Noah. A squared plus B squared equals C squared. Now, is it enough just to know that formula?
No.
I have to know what belongs to what, right? What's the most important part of that? Smear, which one of those is it the most important? I know which of those three is the most important for me to know for sure? C. Why? C is the what? What is it also known as? The longest side. Somebody else give me the word.
Hypotenuse.
The hypotenuse. Okay, it's the longest side. And if I can find the C side, okay, then I'm in good shape, right? A and B are what?
The shorter sides.
They're the two sides that form the
Right angle.
right angle. Good. And those are interchangeable. It doesn't matter which one is my A and which one is my B, right?
Yeah.
Okay, so let's go back to, I'll tell you what, where it says example 1 on your graph. Okay, do you see that? Now you can use, if you'd rather use your board, we need, right there. Okay, if you'd rather use your whiteboard, that's fine. Okay, I'm fine with that. Okay, either one, just kind of write it write it so you understand something. Okay, let's do a really simple one. Okay, let's say I have the point on a graph of 1, 1. Okay, and let's say I have another point on the graph of, we'll say 5, 3. Okay, all right. So if we were to connect these 2 points, okay, and turn them into a line segment. Okay, somebody give me some ideas on how do you think I can use the Pythagorean theorem to find this distance? Kemper?
Well, so like here, the like right angle, would you like?
Okay, I think I know where you're going. Do I have a right angle here?
Yes.
Yes?
Yes.
Where is it?
That's the C side. The line is the C side.
This line is going to be the what?
C
The
side.
C side. So I'm going to have to add something to this, okay? So that I can, trying to find my dotted one here. There we go. Okay, so I'm going to have to add something to this. In other words, I have to put kind of a phantom line here and another one here, because what did I form by doing that?
Triangle. A right angle.
Not just a triangle, but a what?
Right triangle.
A right triangle. I formed a right triangle, and if I have a right triangle, do I now have enough information to find this? Remember, I'm trying to find the blue line, okay? And if I look at that, what is that? What part of my Pythagorean theorem is that?
Side. Hypotenuse.
The C side, okay? The hypotenuse. Now, what if I had done, what else could I have done? Could I have done this?
Yes.
Did I still form a right angle? Are those still going to be the same dimensions? So it doesn't matter, right? It doesn't matter which one you make, okay? But I don't want to do is, I mean, it wouldn't make any sense for me to say do something like this, because this would not form what? That didn't form a right triangle. Is the Pythagorean theorem useful if it's not a right triangle? No. So when I'm here, okay, what can I do to solve this now? What can I do? I need to label some parts, right? Okay, who can help me label some parts here?
I mean, would it be 2, 4?
Okay, well, first of all, what is this going to be?
C.
That's going to be my C. Okay, listen, what is this going to be?
B.
B, okay. And what is this going to be? A. All right, I'm in good shape now. Now I need to determine, how do I know what A, B are? Well, do we have specific units here? We just have units on a coordinate plane, right? So I can say, how many units is it from here to here? 2. How many units is it from here to here? 1, 2, 3, 4, right? So I'm trying to find this C. So what do I need to, first of all, oh yeah, how many steps is this?
6.
6 steps, okay? So let's start with, what's my first step? Christy, what's my first step? Write the formula, good, and what is that formula? A squared plus B squared equals C squared, okay? Now I'm going to plug them in, right? Noah, what's the A? What's the A?
4.
4. So this is 4 squared plus what's the B?
2.
2 squared equals C squared. Okay, do I want you to eliminate steps here and get ahead of yourself? No, okay, because when you have bigger numbers here, these are kind of easy because we can do these in our head, right? But if we have bigger numbers, we want to make sure we do every step so that we don't get careless and make mistakes. 4 squared, what's 4 squared? 8, right?
No.
16, thank you for listening. Okay, what's 2 squared? 4 equals c squared. Well, my next step is to combine these. What is 16 plus 4? 20 equals c squared. Is 20 a perfect square? It's a number with lots of factors. It's a friendly number. It's a compatible number, but is it a perfect square?
No.
It is not.
Mr. Kersey,
Yes, ma'am.
can you do attendance, please?
Oh, I thought I did it. Yes, ma'am.
Thank you.
Okay, so can I find the square root of this? Yeah. You can use your calculators, but I should be able to estimate this. You guys remember estimating square roots? What are the two closest perfect squares to 20? 16 and
4.
16 and 25, right? It's between those two. What's the square root of 16?
4.
Or what's the square root of 25?
5.
So we know it's somewhere between 4 and 5, right?
Yeah.
Is it really close to how many units from 16 is it? 4. How many units from 25 is it? So it's just slightly to the left of halfway, right?
Yeah.
So what do you think a good estimate might be?
4.20.
4.4? Okay, try it on your calculators and see if that's what you get.
Would it be round to the nearest?
Huh?
Would it be round to the nearest 10th step?
Yeah, you can round it. What'd you get, guys?
4.4.
4.4 what?
72.
4.472. So if we rounded this to the nearest tenth, what would this actually be?
4.5.
Yeah, so C is about 4.5, and if we're labeling this, what are we gonna say feet, meters, inches? What are we gonna say here?
Units.
Units. 4.5 units. Okay, very good. All right. You understand how that works now? It's pretty easy, isn't it? Okay, let's look at number 2. Okay, look, example 2. Sorry, look at example 2 on your on your note sheet. Okay, I'll just put those points up here. I have one at 1, 1. I have one at 6, 3. So 1, 2, 3, 4, 5, 6, up 1, 2, 3. Okay, let's connect those. Okay, connect those points. This is really similar to the last one we did. Pretty close. Okay. So how can we find this? We want to use a right triangle on the bottom or on the top?
Bottom.
On the bottom? Okay. So we're going to do a right triangle right here. Does that look correct? Except that I didn't make a straight line. Does that look correct?
Yes.
Okay, so can I use this now to find that distance? Easy, right? Okay. Christy, I need to label the parts of this. What parts should I do here?
C is the green one, or above the C.
C?
Yeah. And then A is below the red one.
Okay. This one? But can it be this one?
Yes.
It can, right? Okay. So A, and this means this has to be what? B, okay. Where's my right angle? Right here? So are we set up, are my legs my AB on this? Yes. Is my hypotenuse the longest side? Is it C? Is it opposite the right angle? So are we set up? Before we go on any further, are we set up? All right? You guys solve this one. Okay, if you haven't already, solve it. Okay, and go through all the steps. Okay, how many of your dimensions look like mine? 5 squared plus 2 squared? Okay, 5 squared is 10, right? Right?
Yes. No. Right, that's 25.
It's 25 right now. I was make sure you're listening. Okay, 25 plus 4. 29. Okay, so the square root of 29, what's the square root of 29? Is 29 a perfect square?
No.
No. So what's the square root of 29? What is it? 5.4. Okay, so we're going to write 5.4 equals C. Is that correct?
No, it's a.
What's wrong with that, Lily?
You have to do about.
About, because we rounded, right? And it's not a perfect square. So I'm going to say 5.4 units is about C. Does that look closer?
Yes.
Okay. All right, look at example 3 in your notes. Okay, what's different about this one? What do you have to do on this one?
You have to make.
You actually have to what?
Plot the point,
Plot the points and then what?
then solve it.
And then find the distance, okay? If you don't plot these points correctly, are you going to be in trouble? You have to plot the points correctly first, right? Okay? So go ahead and plot those points on your graph, and then we'll compare them to see if they look like ours. If I turn it off for about 3 minutes and reset it, then it'll come on for a little while. I messed with it. Don't tell Dave. That's just my trick. It works. It works. See, it finally comes on. You can see, I put that tape up there so you can see it when it comes on. All right, so somebody help me plot these points. Who's going to help? Okay, Sarah.
So first you move the x 0 and then you move down -4
So it's right on the what?
on the y.
On the y-axis, okay.
And
What about the
then,
next one?
On the x-axis you move -3
Uh-huh.
and then it's 0. So
Okay,
keep it
good.
there.
All right. This one's easy because I kind of have my, do I already have my triangle pretty much set up?
Yeah.
If I connect these two, okay, I already see my right triangle, don't I? Okay, now what are the dimensions of this one? Are they the same as what we've already done? Close, right? What is this one? These are 3, and this one is 4, and what is this one? We don't know. Well, let's label our parts. What are our parts here? Smear. Which one's the C? This side? Okay. Which one's my B? Allison, which one's the B? The 3, okay. Which one's the A? That one. Okay, let's write our formula. So A squared plus B squared equals C squared. Okay, let's plug in our numbers. So 4 squared plus 3 squared equals C squared. What's 4 squared?
16.
16 plus, what's 3 squared?
9.
9. Ooh, I see a perfect square coming. What is 16 plus 9?
25.
25. This one's easy. We actually get to use a what here? An equal sign, because 25 is a perfect square. So 5 units equals what?
C.
C. Good. Now, look at this. It doesn't look like it doesn't go straight through these, does it? In other words, you understand what I'm saying? It doesn't go straight through one half and the other half. It kind of does this one, then it drifts this way, but apparently if you put all these together, it is exactly 5. Okay? Does all of this make sense?
Yes.
Do we have any questions on how to find distance on the coordinate plane if it's not on the same line? No. Now, do you think on your worksheet there's going to be some obvious ones where they put 2 points on the same line and they ask you the question how to find the distance?
Yes.
Okay? Don't make this mistake, guys. Okay? Don't do this. If I have these 2 points, okay, don't say, well, let's go down to here and we'll make this into a right triangle. Okay? If these are the 2 points you're given, all you have to do is count the units, okay? Do you sometimes overthink things? You're overthinking my question right now. Do you overthink things sometimes?
Yes.
Yes.
So all you have to do is count the squares in between the 2 points.
Yes. Okay. Any questions on that? All right. I'm going to pass out your worksheets. You're probably going to have to show your work on a separate sheet. I don't know that there's room. When you get to your worksheets, number 14. Okay, actually, let me pass them out first. Okay, pass these out. Can we get the lights, Katie? Okay, look, when you get your worksheet, look at number 14. You get to make up your own problem there. Okay? Make up your own problem and show me how you solved it. Okay? You can tell me, okay, I'm going to have 1 point at 8, 10, I'm gonna have 1 point at negative 7, 5. Okay? The more creativity you put into that problem, the better. Okay? Does that make sense?
Yes.
Okay? So you're gonna make your own problem and solve it for me, and then I'm gonna check your answer to make sure you did it correctly. Okay? Look at numbers 1 through 6. Somebody read the directions for me. Sarah, read those directions. 1 through 6.
I don't have the paper yet.
Oh, sorry. Christy, read those directions for me, 1 through 6.
Okay. Find the distance between each pair of points whose coordinates are given. Draw to the nearest 10 if necessary.
Okay, so on numbers 1 through 6, they're already graphed for you, right? Right?
Yes.
So what are you gonna have to do from those 2 points? Turn it into a what? A right
Triangle.
triangle. Okay, whether you go above, whether you go below, doesn't really matter. But you will find those distances. Now, on the 7 through 12, what do you have to do?
And then,
Graph the pairs and then what? Then find the distance. Okay? You understand? Okay, on the other side, number 13, just read it, okay? You're graphing those points. And then on number 14, we already talked about. Question?
So on 14, do we just write coordinates? Or do we just write the coordinates? So these on the graph for 14.
Okay. Look at number 13. Okay, you have 2 similar artifacts. One is at one position, the other is at another position. How far apart are the outer artifacts? So you graph 2 points and then ask a question, how far apart are the points? And then show me your
Make
answer.
like a story, and you have to ask like how far apart they are.
Yeah, there you go.
And then make it on the one to have it, the archaeologist one, just change the numbers.
so there has to be a storyline.
Oh my gosh, guys, come on. You're overthinking it again. Billy walks to the store. He takes 12 paces to the right and ends up at this point. Come on, make something up. Be creative.
For number 1, all we have to do is just count how many.
Yeah, number 1, are you making a right triangle on number 1? Remember what I said about that? Be careful. Do you need a right triangle? You do not need a right triangle on that one.